All right, here we go. So the 6 different situations from any ratio is obviously a point that we have to continue to reinforce. It comes back to the ratio tables in a lot of ways. So in this situation that I've written here, there are 4 chickens for every 6 cows on the farm. We obviously have chickens, and we have cows, and then that idea of total has to come into play. And so I'm just going to call this total animals. This is the most straightforward kind of ratio that we see. We see it as part-part. They give you the parts, and then you calculate the whole. So 4 chickens, 6 cows, 10 total animals. I can simplify that to the simplest whole number ratio form. I'm going to divide both of these numbers by 2, or all 3 of them really. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 plus 3 is 5. 10 divided by 2 is 5. That does check out. So the simplest whole number ratio form would be 2 chickens to 3 cows. Or, so I could list this as 2 chickens for every 3 cows. And really I should start it with there are. And then use for every in the middle. So I can list 6 of these now from this table. And they all start with there are. There are 3 cows for every 2 chickens. 2 to 3, 3 to 2. There are 2 chickens for every 5 animals. There are 5 animals for every 2 chickens. 2 to 5, 5 to 2. There are 3 cows for every 5 animals. And there are 5 animals for every 3 cows. 5, 6. This would be 2 to 3. It could also be written as 2 to 3. 3 to 2. 2 to 5. 5 to 2. 3 to 5. And 5 to 3. And you can see they all come from this original table. 2 to 3. 3 to 2. 2 to 5. 5 to 2. They're all in here, all 6 situations from one ratio. And that was what the first mini quiz was on. Looking down here, this one's a little more complicated. This is what we call part whole that they've given here. So Jack has 20 coins, 14 of them are heads up. So the idea of total is given here, and you have to figure out the other part. Knowing what we know about coins, we can say, well, if we have heads up, then we must have tails up. And then we have total coins. Always starting off with those labels, part, and whole. So here, if I have 20 total coins and 14 of them are heads up, well then by subtraction I know that I have 6 that are tails up. 14 plus 6 is 20. I can simplify this ratio conveniently again by 2. 7 plus 3 is 10. And then I can come up with those 6 situations again. There are 7 heads up for every 3 tails up. There are 3 tails up for every 7 heads up. There are 7 heads up for every 10 total coins. There are 10 total coins for every 7 heads up. There are 3 tails up for every 10 total coins. There are 10 total coins for every 3 tails up. Those 6 situations are incredibly important to be able to draw out of this because any ratio word problem could ask for any one of those ratios, and the student has to pay attention to the order that the question asks for. So my final answer could be 3 tails up, could be 7 heads up, could be 6 tails up. They could ask for how many are heads up if you have 100 coins. Then you can use your ratio table to say, well, I could go from the 20 or the 10, doesn't really matter. Here I'm multiplying by 5. Here I'm multiplying by 10. That's a little easier for me to calculate. So here it's 30, and here it's 70. So if I have 100 total coins, I should have 30 tails up and 70 heads up. Things can get more complicated. I could say, well, what if I had 25 coins? That's a little more complicated for me. Looking back, I could divide 100 by 4. I could divide 10 by 2 and then multiply by 5. I might do that. 10 divided by 2 is 5. 3 divided by 2, I'm just going to leave that as a fraction of 3 halves. And 7 divided by 2, I'm going to leave that as 7 halves for now. And then I'm really multiplying by 5. 5 times 5 is 25. So 3 halves times 5 wholes is 15 halves. And 7 halves times 5 is 35 halves, which I could simplify here if I wanted to 7.5. Let me think here. 35 divided by 2 isn't what I'm going to be able to do mentally at this moment. 17.5. So if I had 25 coins, I should have about 7.5 tails up and about 17.5 heads up. Is it realistic? No, but it's a ratio. And it's saying if I would have 25 coins, here's what I would expect. But again, I could have those 6 different relationships come out of it. And I'm going to do those 6 relationships from here just so that you can see them again, because that's kind of the point of why I started the video. Got off on a little tangent there. Got excited about ratio tables. There are 7 heads up for every 3 tails up. I guess I could have called it heads down as well. There, well, my handwriting's going to get worse as I go down the paper. 3 tails up for every 7 heads up. There are 7 heads up for every 10 coins. There are 10 coins for every 7 heads up. There are 3 tails up for every 10 coins. There are 10 coins for every 3 tails up. 1, 2, 3, 4, 5, 6. 6 different relationships from 3 different ideas. And again, we could write this as a fraction, or we could write it with a colon. 3 to 7, 7 to 10, 10 to 7, 3 to 10, and 10 to 3. Order is important. Now, the last thing I will say is not every question is going to ask for this, but if they ask for those relationships, there they are. Sometimes they will ask for just a specific answer with a label, so you have to pay attention to what they're asking for. But this is a little mini lesson on finding those 6 situations from one setup.